In C and C++, getting from source to binary means wrangling a zoo of tools, make files, shell scripts, auto tools, CMake, and cryptic linker flags, each with its own dialect and failure modes. Rust solved this by making Cargo part of the official toolchain. Ferris hands the developer a single, tidy toolbox labeled Cargo. One tool, one entry point, no menagerie required. Inside that toolbox, Cargo performs 4 jobs. Project scaffolding with Cargo new, dependency resolution against crates.io using Cargo.toml, compilation orchestration by invoking rustc for you, and running the built artifact with Cargo run. Compare the workflows. On the left, manually compiling Rust means invoking rustc, pointing the linker at the right path, hunting down libst, and stitching it all together. On the right, Cargo run does exactly that in one command. One subtle but powerful Cargo.toml field is edition equals 2021. It is not a version of the language. It locks in which breaking change rules apply to that crate, on a roughly 3-year stable cycle of 2015, 2018, 2021, and 2024. Welcome to this hands-on walkthrough of the Cargo scaffolding workflow. We'll explore how Rust's built-in package manager generates a new project, then inspect the resulting file structure and configuration. By the end, you'll understand exactly what Cargo new produces and why the layout matters. We start by running clear to give us a clean working canvas. This is a common best practice before recording or screenshotting terminal output. It ensures our demonstration is easy to read from the very first frame. The which command locates the executables for Cargo, the package manager, and rustc, the Rust compiler. Seeing both paths confirms the Rust toolchain is properly installed and accessible from our shell's path. Before scaffolding, we check Cargo new. Help and pipe it through head-10 to see the top of the help text. This confirms the subcommand exists and shows the available flags like bin, lib, and vcs that control project generation. Now we scaffold a new project by chaining cd/tmp and Cargo new hello_demo into one command. Cargo creates a directory called hello_demo containing a Cargo.toml manifest and a src/folder with a starter main.rs file. Listing the src/directory confirms that Cargo created exactly one source file, main.rs. This is the entry point of our binary crate, and it's where the famous hello world print statement lives. Finally, we inspect the generated Cargo.toml manifest. The package section defines the project name, version, and Rust edition, while dependencies is empty and waiting for crates to be added. This file is the heart of every Rust project. It tells Cargo how to build, test, and publish your code. Every Cargo project follows the same predictable layout. The manifest declares intent, the lock file enforces reproducibility, and the target directory holds the build output. This is the anatomy of a Rust crate. Cargo.toml is the project's declaration of intent. The package section holds metadata like name, version, and edition. The dependencies section lists external crates like CERD, an optional profile. Asterisk sections tune optimization and debug behavior. src/main.rs is the crate root for a binary. The fn main function is the entry point, and Cargo implicitly treats every file under src/ as part of the crate. No explicit module declaration required. Cargo build compiles your project and drops the binary at target/debug/hello_demo, printing compiling hello_demo version 0.1.0, and finished. But it does not run it. Cargo run goes one step further. It builds if needed, then executes the binary, printing running target/debug/hello_demo. Cargo build. Release trades longer compile time for an optimized binary at target/release/hello_demo. The manifest declares intent. Cargo enforces reproducibility. Cargo is Rust's build system and package manager, and it does far more than just compile code. It scaffolds projects, manages dependencies, and produces a structured target directory of build artifacts. In this demo, we'll create a brand new Rust project from scratch, verify the generated layout, and inspect the manifest Cargo writes for us. Before building anything, we confirm that both Cargo and rustc are reachable on the system path. The which command prints the absolute path of every binary it finds, so seeing 2 full paths means our Rust toolchain is installed and discoverable. If either line were missing, we'd need to install Rust through rustup before proceeding. Next, we peek at the help text for Cargo new, so we understand what flags are available before we scaffold a project. Piping the help output through head-10 keeps the screenshot readable, and shows the most useful options at a glance: package name, edition, registry, and binary versus library selection. This is a habit worth keeping. A quick Cargo new help removes guesswork later. Now we create the actual project. The cd/tmp part moves us into a scratch directory so we don't pollute the home folder.
And Cargo new hello_demo scaffolds a complete Rust package named hello_demo with a sensible default layout, including a Cargo.toml manifest and a hello world main.rs source file. Cargo prints 2 confirming lines. It created the package and committed the initial files to a fresh Git repository. With the package created, we list the contents of its src/directory to confirm Cargo wrote the expected source file. Cargo always generates a single main.rs4 binary crates, pre-filled with a classic hello world program, so you can compile and run it immediately. Seeing exactly one entry here tells us the scaffold succeeded, and our entry point is where it should be. Finally, we inspect the Cargo.toml manifest that Cargo generated for us. This file is the heart of every Rust package. It declares the package name, the addition of Rust we're targeting, and a placeholder dependencies section ready for crates to be added. Notice how minimal it is. Cargo's defaults are deliberately lean, so you only add configuration when you actually need it.